Hi again, Rother fam. We have been talking about chemical formulas, kind of how they stand on their own. Well, they also react with other chemicals to make what we call chemical reactions, and we're going to look at two. So one day when I'm out, I think next Monday, you're going to have a worksheet that says, is it following the law? Is it following the law? What law do you ask? The law
of physics.
Of conservation the law of conservation of mass. All right, we are going to then divide our paper into two parts. We're going to write down two equations. Okay, the first equation we're going to write, I would start kind of over here on the left because it's a rather long equation. So we're going to do two molecules. This is called a coefficient. We're going to have two molecules of C8, H8, and they're going to react with 25 molecules of oxygen. That's a lot.
Plus.
All right, now this arrow we call yields. So 2 molecules of this, 25 molecules of this reacts with or yields 16 CO2 and 18 molecules of H2. All right, these compounds right here are called reactants. If you want to remember, these are the little ants that are going to be doing the reacting. So the reactants, the ants that react are on the left. The arrow is, okay, that is wrong. Y-I-E-L-D-S, yields. And these are the products. Okay, so those are the products. 16 molecules of carbon dioxide and 18 molecules of hydrogen. Okay, now the law of conservation of mass says that matter cannot be created or destroyed. Okay, we're going to draw a little line just to separate our reactants from our products, and we're going to count our different, how many atoms of each element we have. So I see carbon on this side. I see we have hydrogen, and then move over and we've got oxygen here. All right, the law of conservation of mass says we're going to have the same number of each of these over in our products. So if we have, here we have 8 carbons, right? But there is a coefficient, so we're going to multiply that 8 by 2 to get 16. All right, let's move over. We have 8 hydrogens, correct? So we've got 8 hydrogens. We're going to multiply that by this coefficient. So we'll also have 16 atoms of carbon. I may have said molecules over here. I mean atoms. So we have 16 carbons, 16 hydrogens. Let's move over here. We have oxygen 2 times, but this coefficient applies. So we're going to multiply 25. So 50 atoms of oxygen. Okay, now let's go to the product side, you notice all these elements, or these elements have rearranged themselves. Nothing's the same, is it? But they still have to have the same number of elements and atoms. So let's look here. We have carbon. We still have oxygen. And we still got the hydrogens. All right, well, let's count. So there's one carbon right here, correct? All right, but there is a coefficient of 16. So we need to do 1 times 16 equals, that's right, 16. All right. Okay, so right there, they check out, don't they? So we didn't lose any carbon, so right now it's following the law. So let's check out oxygen. We have 2. 2 times 16 is, y'all check my math, is it 32?
Yeah, it is.
32, thank you. Okay, oxygen, check it out. What happened? Okay, in nature, the law of conservation of mass says you should have 50 oxygens over here. So is this equation following the law of conservation of mass?
No.
No, so already we can say not or no.
Looks like a lot of equations.
Yeah, that's a big equation. All right, do I move on? Okay, we're gonna write another equation. This one's quite big too. Okay, we're gonna have 3 molecules. Let me zoom in here. 3 molecules of that's an S. 3H2SO4.
You said O4.
3H2SO4 plus, we're going to have 2 FEs. All right, so these are the reactants, right? And from here on out, when we do these, we'll put R. And then the arrow means yields. Okay, we'll move over to, what do we call these guys over here? We call these the products. All right, and the products here are Fe2, and we have parentheses here. We're going to get a little more complicated counting atoms. So we have Fe2, SO4, parentheses around the SO4, subscript, and then 3H2. Now, while we're here on the product side, let's look at what elements make up these products. I see iron. What's the next element you see? That's right, good, sulfur. And then we have oxygen, and then we have hydrogen. So let's put oxygen and hydrogen. Now we're just gonna go from left to right, left to right. I see Fe, how many irons? 2. Looks like we have 2. All right, look at the S. There's 1, correct? Okay, it's kind of like the distributive property, or maybe it is. We're gonna take this 1S, and there's a subscript, so the subscript is gonna be here. So we do 1 times 3. There are 3 sulfurs, okay? Now, this is kind of tricky. We have oxygen 4 times inside the parentheses. So we're gonna take that 4, and we're going to multiply it because it's there 3 times. So 4 times 3 equals, check my math, 12. And then we have 2 hydrogens, but we have 3 molecules of it. So we're gonna do times 3 equals, thank you, 6. Okay. All right, we're gonna draw a line here to separate. All right, it looks different over here, doesn't it? This Fe that was by itself is now part of another compound. All right, so we've got H2. So we have hydrogen. We have it 2, the subscript is 2, but we have a coefficient. So we're gonna go times 3 equals 6. All right, let's move over. We have 1 sulfur, but there's that coefficient we can't forget about. So we have 1 sulfur times 3 equals 3. Let's move over to oxygen. We have oxygen 4 times because of that subscript, but we can't forget about the coefficient. So we go times 3 equals 12. And then we can't forget about our 2 Fe's. So we have 1 times 2, correct? Yeah. Okay, look at the big picture and compare. Did we end up with 2 irons like we started with? Yes. Yes. Did we end up with 3 sulfurs that we started with? Good. Did we end up with 12 oxygens? Yes. All right, and then we ended up with, hydrogens. Are we good? Okay, so this one is following the law. And I really appreciate your attention, first period. Thank you.